Unit 4, absolute value notes. We're going to talk about solving absolute value equations. So a compound equation or inequality has more than one piece, joined by the words and or. And requires that all things are true, or requires only that one or more things are true. The absolute value of a number is its distance on the number line from 0 to the left or the right. Written as the absolute value of x is equal to c. So you could be c units to the right, or you could be c units to the left. For instance, the absolute value of x is equal to 5. This equation translates to a number is 5 units away from 0 on the number line. What is the number? Well, it could be plus 5 or it could be negative 5. Steps for solving absolute value equations. First thing you want to do is isolate the absolute value. After that, we will split the problem into two equations. The first will look just like the original, but without the absolute value bars. In the other, take the opposite of one side, but again, use no bars. So if you take a look here, we have x minus a, which looks what? Just like the original. So this is x minus a is equal to c. The other one looks just the opposite of the original, still x minus a, and it is equal to negative c. Once we do that, we're going to solve each of the equations, and we must, I can't stress this enough, we must check our answers. So note, the absolute value of a quantity is a distance. So the absolute value of a quantity cannot be a negative number. We're going to have to check for what we call extraneous solutions, especially when there are variables on both sides of the equation. Extraneous solutions, you did the problem correctly, but the value didn't work. Solving absolute value equations practice. The first one, we are going to subtract 7 on each side. This is our attempt to get the absolute value by itself. Now we have 2 times the absolute value of 3x minus 4 is equal to 10. We will divide each side by 2, and we get the absolute value of 3x minus 4 is equal to 5. So now we're going to create 2 equations. 3x minus 4 is equal to plus 5, and 3x minus 4 is equal to negative 5. Set up our 2 equations. Solve. We find out that x is equal to 3, or x could be equal to negative 1/3. Let's check it. We checked it in the calculator. Second math takes you to ABS, which is absolute value. So we have 2 math, absolute value, 3 times 3 minus 4, close up the absolute value, plus 7 equals 17. We hit the second entry and bring that same equation back up, and we substitute the 3 for negative 1/3, and they both work. Yay us. Number 2, we already have the absolute value by itself, so we go straight in and we set it up. 2x plus 1 looks just like the original. And then we have the opposite of the other side. So it's 2x plus 1 is equal to negative 11. 2x plus 1 is equal to 11. Subtract 1 on each side. 2x is equal to negative 12. Divide by 2. X is equal to negative 6. Subtract 1 on each side, we get 2x is equal to 10, and divide by 2, we get x is equal to 5. We plug it back in. Oh, and it doesn't work. We plug it back in, and it doesn't work. What happened? No solution. So no matter what we put in, it's not going to work. Well, take a look. Let's step back up here. Dot, dot, dot. An absolute value can't equal a negative. We could have said no solution from the start, because the values that come out of absolute value are positive answers, and a positive answer will never equal a negative answer. There you have it. Let's try the next one. Here, let's not just assume because there's a -7 that it's not going to work. Let's isolate the absolute value. So here we go. -4 times the absolute value of 5x plus 1 is equal to -12. We're going to divide each side by -4. Yeah, now we get absolute value of 5x plus 1 is equal to 3. Now we're ready to set up our two equations. 5x plus 1 is equal to plus or minus 3. Solve for both. We get x is equal to 2 over 5 and x is equal to -4 over 5. Checked it and it works. Wow, look at this one. Be careful. We have isolated the absolute value, and we have to set it equal to the opposite side, the other side, excuse me. So we're going to set it equal to plus or minus 5w plus 37. So if it's 5w plus 37, nothing changes. And over here, we have to distribute this negative. Let's see what happens. We continue to solve, and we get w is equal to -38, or w is equal to -4. We have to check it. Oh my, -38 did not work, but -4 does. So how many solutions to this one? Only one. So let's try the next one. Now we have a fraction. The question is, do we have absolute value by itself? No, we do not. So in order to get absolute value by itself, it's being divided by 8. So guess what we're going to do? We're going to multiply by 8 on each side. Let's see what we get. We get these two answers. We set it equal to the positive 24 and -24, and we solve both. And we get P is equal to 20 over 7, or -4. In number 6, what we need to do is we need to subtract 5 on each side. So when I subtract 5 over here and 5 over here, I get 0. And then I have the negative absolute value of 8x minus 6 is equal to 0. I want to tell you, do not even try to distribute. You cannot distribute through absolute value bars. We're going to divide each side by -1. See what we get. The absolute value of 8x minus 6 is equal to 0. We don't have to take the positive or the negative because 0 doesn't have a positive or a negative. So 8x minus 6 is equal to 0. We add 6 to both sides and divide by 8. And last, we simplify. That concludes your lesson on absolute value.